right, hello everybody. Thank you for coming. Good morning on day 3 here, or day 2, whatever it is, BioIT World. So my name is Ari Berman. I'm CEO of BioTeam. I'm going to moderate this session today, and I'm really excited about the information we're going to talk about today. So these wonderful folks brought BioTeam in about 8 years ago to really help this effort of bringing technology, data science, and bioinformatics to the African continent. And so it's been an absolute honor to be able to do this and to continue doing this and working with these great people. We've met amazing people from the continent. And so today, this is really sort of background, what's going on, what the impact is of the ACE program, the African Centers of Excellence in Bioinformatics and Data Intensive Sciences. And we're going to have 5 talks that sort of go in a row, and then we're going to have a panel at the end to answer questions, be interactive, that sort of thing. So, and I'm, everyone here is amazing, but I'm really excited to have Dr. Jadi Jingo here, who's one of the scientists from Uganda who came in to talk to us today. So with that, I will have Mike Tartakovsky come up and lead us off.
Thanks, Ari. Good morning, everybody, and again, thank you for coming. So I work for the National Institute of Allergy and Infectious Diseases, which is one of the 27 institutes in the National Institute of Health system. So, and as Ari said, I will talk about one of our programs here, the African Center of Excellence in Bioinformatics and Data Intensive Science. I always like to start, with this quote from our former director, Dr. Francis Collins, that it's clear that one of the areas that is probably in need of the investment is data science. I don't think I need to prove that point to anybody in this room. That's one of the reasons we're here. But this statement, even when it was said 5 years ago, still very valid, and we still need to explain why data science is so important even these days, but not, I hope not to this audience. But when we look at the landscape of the modern biomedical research today, these are the things that we basically discovering, and that's how we're building, our operations here. Virtually every protocol today, modern protocol, they require some level of the computation, okay? About half of the work right now require high performance computing. That will increase to, well, it probably never will reach 100%, but will be very close to the 100%. Therefore, we need to treat our computation as a laboratory tool. It's becoming, the same way as any other tools in the lab that are being used here. Data centers are research instruments today, okay? And that's how we need to keep treating it, okay? So the other problem that is very specific to low-income countries and specifically to the Africa continent is that the researcher cannot take advantage of all of these computational techniques due to lack of access to training, infrastructure, and long-term support. So that's how the idea of African Center of Excellence were conceived. We did back in the day, and I'm talking about early 2000s, about somewhere between 2004 to 2010, a lot of training in the brand new disciplines, bioinformatics in Africa. Everybody wants to learn about bioinformatics. But results of those sessions was, okay, now we learned all these wonderful techniques. Now we're familiar with all these great tools. How we can use them? That was the main comment that we were receiving. And we basically say, okay, we need to go and try to revisit how we're approaching that access to the modern computation in Africa. So the other important point that I want to bring here so everybody understands, we work in the area of the infectious diseases. It's a global threat. But digital environment is not a global tool yet. There is a lack of access to the digital environment in many places in the world. When you look actually at the burden of the infectious diseases, most of it happens in the low-income countries, but at the same time, they're also low IT resource settings. 95% of global cases and deaths are attributed to those low-income countries. However, they lack access to the technological capabilities to address those issues. So, and this kind of, again, I put this example of the tuberculosis here. Believe it or not, it's still a huge problem in the world, okay, especially of the HIV. So, with all this in mind, to democratize access to the infrastructure, we start thinking about African Center of Excellence. This program is envisioned, as a 3 pillars here. In order to have, it's not enough just to build an infrastructure, okay? Any program that we want to build starts from the education. And that's why I'll talk a little bit later about our partnerships. They always build with some local university as one of our partners. So the second is post-university training. That's where the infrastructure that we are building comes to mind. That's where we are right now in the second phase. We are approaching the third pillar where we want the centers to become actual regional service centers for the bioinformatics and data centers and data intensive science in West Africa and East Central Africa, where we have 2 of our centers right now, where the centers will become eventually self-sustained for the contributions by the grant funding organizations, okay? And other PIs who can use their funding to leverage work of that centers. So in this slide, there are some details there. You will have access to the slides. I'm not going to go through all of this, but there are certain things that I want to highlight, especially in the area of education, because they're important. It's not only the problem of the access to the tools. It's sometimes, in many cases, the absence of the faculty that is in those universities. So to build the tele-learning centers was one of the first priorities for us. So partnering organizations in the United States, Europe, and all over the place can deliver the lectures, other tools, to those centers, at the same time assisting in growing faculty in those universities that are part of this. So it's a degree program. We recently start investing significant amount of money into the virtual reality learning. It proved to be a very efficient tool. So Dawzi probably will talk a little bit more about what we do with the virtual reality there. But again, all of what you see on this slide are parts of the or methods to achieve the objectives of our program. We're optimizing those plans for the regional needs. There are different needs in Mali, there are different needs in Uganda. But what we're trying to achieve here is to use the standardized curriculum that was developed by the NIH Common funded H3A, who developed, the standardized curriculum. We want to build this program scalable. So that's all what we do. The model of ACE is like nothing you've seen before. Okay, this is not your typical government program that is funding money to some colleges, universities, in order to develop this. This program is being run as a public-private partnership model, where no direct funding or money changes the hand. It's all, if you want, a coalition of willing who understand the problem and provide in-kind contribution to this model. So each of these, and again, I probably missed some of the partners here, so I apologize for that, because it's a growing model. It's more and more organizations who are understanding the issue and want to participate in the program. So I cannot do official recruitment here, but again, if somebody interested and want to, if this is what you see as a problem, we'll be happy, to talk to, actually not we, but Foundation for NIH, we'll be happy to talk to your organizations and to get you participation in those programs, okay? But we have companies who donated equipment and provide consulting. We have organizations that provide training, research space. That's usually our local partners, the University of Science, Techniques and Technology in Bamako, Mali, and Makerere University in Uganda. Our successes always depend on the connectivity. So we spend a lot of time, with the local research and education network. So Maliran and Renew, Research and Education Network of Uganda, are our partners. And all of this coordination of training, infrastructure, technical support is done by the National Institute of Allergy and Infectious Diseases. Okay. The glue between all of these components is a foundation for NIH. Without their support, this program wouldn't be possible at all. The program is governed by the Global Council. It's a very representative council. You can see it's co-chaired by Professor David Servada from Makerere University and Dr. Jessica Kissinger from University of Georgia, and include representatives from many African countries, as well as from the United States. So I will stop here. Or is mine still? Yeah, that's yours.
No, those are yours. I put them all in. So you can skip forward.
Okay. So yeah, I will skip forward then. And yeah, and pass it to Dr. Jingo, who is running our Uganda Center Director for Uganda, right?
Right. Good morning, everybody, and very excited to have you here today to listen to our session. Daudi Jingo again, the Director of the African Center of Excellence in Bioinformatics and Data Intensive Sciences. Just to take you through some of the work that we're up to. So, like Mike just said, this is a transcontinental network. Right now, being based at these two centers on the continent, but really filtering through networks in other countries. A lot of colleagues from Kenya, from South Africa, and a few from Kigali are actually already using these resources and tapping into them. So it's really a growing network, and it's really centered around trying to enable research using all these different tools. As you might see, those, the set of tools on the left is all fairly new technology everywhere in the world, but especially for us in Africa. And everything is really just beginning to come off the ground to build capacity in these areas. So, and like Mike said, this is especially important because of the cluster of biomedical research that is required in our ecosystem, precisely because it is aware of local issues and it's important to engage people there. And so there's a whole breadth of research that is going on and that is being enabled by this network and these technologies. Mike did mention infectious diseases, but increasingly also non-infectious diseases. We're actually currently working to build a partnership with the Fred Hutch Cancer Institute in Seattle, I think. So we're beginning to work with them because we're setting up our working with them to set up a sequencing center in Kampala to try and do cancer research. And Chris, who will talk later, is kindly helping with that effort also. But the idea is that, if we thought that infectious diseases are hungry for computational resources, actually non-infectious diseases are even hungrier because they're mostly centered around heavy human genetics and human genomics, and that consumes a lot of resources. So these efforts are being supported along the area of bioinformatics and the area of data sciences with all the different types of analysis that you see there. And of course, these require both compute and also require storage. And of course, AI is already and ChatGPT, but you see natural language processing there. We're actually already plugging into it because it turns out natural language is, of course, an important part of research, and we're shortly going to see how in so many different ways, but at least in one of those ways, we already found that relevant before even the advent of ChatGPT. And it's also a compute-hungry sort of application for all the reasons that you know. And so because of that, compute, storage, processing was a major glitch. Like Mike said, it's as important as the laboratory itself, the classical biomedical laboratory itself. It's the new laboratory, so to speak. And so prior to 2019, when this started, this was a major glitch in our ecosystem. And a lot of research that we do now was absolutely not possible. We could only go as far as our small laptops and desktops could take us. And that glitch was both the computational resources, but then of course also, like Mike said, the human skills and training that was required to do that. So those three things at the bottom were only getting droplets of the data that was required in terms of compute, but also in terms of storage and in terms of the research. And over the last 4 years, since 2019, 2018, really what has happened is that through collaboration with a lot of colleagues in this room from NAD, from BioTeam, and support from the NIH, research data, and a lot of other partners, the Infectious Disease Institute in Uganda, this bottleneck has been dragged outwards, and we're seeing a lot of data now filter through. This is really just an imagery to show that we're now accessing a lot more data, a lot more compute, and able to do more things that are data-based, including research, because of this enabling environment, mostly based around provision of compute, provision of connectivity, provision of human skills, and training, all this recipe, which is absolutely required to get this kind of research going. And so this is just a picture of the class, the inaugural first lecture that happened in this telecenter. By the way, on the campus, this telecenter is super popular because the room is all pimped up. It looks very, it looks like this. And you won't believe it, but to undergrads and even master students, that's a big pull factor. Just sitting in a cool room actually influences the way they think about what they're doing and the drive that they have and the enthusiasm. And you could almost see this. So this happened 2019, and over the last 4 years, it has really been a flyaway success in terms of the individuals that have come through this pipeline. Master's students trained at a master's level and students trained at a PhD level. And this is at the two locations in East Africa, in Uganda, and in Mali, in West Africa. Of course, Uganda is quote unquote English speaking and Mali is French speaking. So you have that Anglo-Francophone capability, which on the African continent is, of course, is important because of our colonial history. Being able to reach those demographies is important. And I think, I don't know how those locations were selected, but I think there was some insight there. Now, if there is anything that is going to make a really big difference, it is these training programs. And these individuals, we're going to see some of the work that they're doing, some of these students, and then talk about where they're ending up, and what a difference they're making. So these are just current students, so not the people that already graduated. These are just current students, and as you can see, they're doing a whole range of research. By the way, it's also gender sensitive, right? So I think our classes are typically about 35 to 40% female, which in a STEM field in our ecosystem is totally transformational. A few years ago, that was definitely not the case for the STEM. It was easily 9-1. So, but anyway, so there's a whole range of research. As you can see, there's predictive research, application of machine learning in tuberculosis, in antimicrobial resistance, in sequencing, in metagenomics, and we'll talk a bit more about the results coming out of that. Cryptococcus neoformans, which is a cause of meningitis, which is also a very prevalent infection. And of course, all these things that you see here are playing out in the context of HIV, which, so they have very direct connections with HIV because of what it does with immunity and enables a lot of other infections. But just having these students being able to engage this kind of research at this level is already something very impactful. And some of their work has filtered into publications already in decent journals. And that is our first class of excited graduates. All of them very looking forward to applying their skills, and actually they've been very well trained. So those are master students, but we've also had training at a doctoral level. And this is where it gets very interesting, because we clearly need these skills in the ecosystem. We're hungry for them, but you know what? So are you guys. So some of these individuals have actually been quote unquote poached. I think Savannah on the extreme right on the top is heading off. He's actually already, I think, doing a postdoc in Maryland. Ronald, second from the left, has already been approached by a lot of individuals, so we're trying to hang on to him. Gerald on the top left is already off, but he stayed in ecosystem. He's in Addis working with Africa CDC, but I think he's being vibed by some other institution in the US. Grace, second from right, she's already here working with the CDC in Atlanta. Bottom left, John and Amujal. We have them back, but they spent some time at Baylor, and that also has its own consequences. Anyway, but we're excited because that means that the quality of training is that good, that these individuals are being competed for by institutions from across the world, but we have to figure out ways of hanging on to them as far as we can. But sometimes even when they come here, they eventually bring back value. I myself worked for the CDC once in Atlanta and managed to get back. So, and this is some of the research that they've already done and published, those PhD students, including molecular simulations of POL1, which is very important for CKD, which is an issue for us because of its relationship with schistosomiasis, which is also a neglected tropical disease in our environment. It's sort of like the same thing as sickle cell and malaria. So we've already had several publications actually out of that area. Killer cell immunoglobulin diseases, classical bioinformatics papers like Quasiflow by Sekajiri, and then some program-related work, including one by our colleagues at NIAID, and then bioinformatics mentorships and all the other types of work we're doing. We're supporting the DSI Africa Network. This is a transcontinental network for data science. So we're supporting it in terms of infrastructure, data, tools, and of course, we're also providing virtual reality-based solutions to training, especially to training basic life support in the COVID-19 context, in surgery, virtual surgery training programs, which are already coming up because of the huge need for surgery. And of course, these resources are also supporting the Sickle Cell Africa Network, which is also a cluster of different clinics across the continent that is tracking pediatric sickle cell disease. And we're helping with these resources are being used to provide them with the database resources that they need. This is a natural language process-based application that we built during COVID-19 to try and alleviate the burden of communication that health workers were already having, because there's so much misinformation and a lot of their time was being spent answering questions. So this was our attempt at using these resources to support that kind of work. And of course, some of the younger guys are excited, so they're building apps. This is an example of an app that is being used to for epileptic adolescents to help them handle their behavior, track their symptoms, and that sort of thing. So it's been a very fruitful relationship that we hope to continue to build, and it's a growing community. All those excited faces. This speech was about 2 years ago, but I think it's a lot bigger now. That community has grown and continues to grow. And of course, like Mike said, this is a collaboration of so many supporting entities that we've been very privileged to work with and hope to continue working with going forward. Thank you very much.
Well, that's a hard act to follow, Dowdy. Thank you, Dowdy. I mean, I feel like we can all sit down now, but I'll carry on. Good morning, everyone. I'm so happy to see faces that I know from my NEI team and family. Thank you for coming. And Bio team is here as well. I stand here representing Bio team today as one of the people on this amazing group. So I will kick off. I'm going to talk about, so I can just give you a little bit of background about myself. I joined Bio team 2 years ago, and I joined Bio team out of this sort of push to do good in the world. And this project that Bio team works on really resonates with the things that I really care about a lot, which is I care a lot about equity in science and really women of color in science. I feel like it's so underrepresented. So I care a lot about that, and so does Bio team. And also I care a lot about, my background is working with farmers, and 80% of the farmers on the continent are women. So I just care a lot about those things. I feel like the more energy we put into equalizing the spaces, the better we'll all be. So that is, I feel so happy to be on Bio team because every person on Bio team has that exact same mentality. So I'm happy to have joined this crew who has laid down huge foundational groundwork for me to talk about what I'm going to talk about, which is I do this small part with my colleague Shane and another colleague named Javier, who's not here with us, but we have been working on these virtual engagements. And really what we do is we conduct office hours every 2 weeks. And this is all about building relationships with the students, making them feel comfortable to ask questions, providing a space for them to bring issues with their code, things they're interested in with data science, all of those types of things. We let the students drive the agenda, right? We work with them. So we're also trying to understand, and Shane's going to cover the full details about the network and the hardware and all of that. I'm just going to talk about the sort of other thing, the work we're doing. And so the first thing that we did when we started this virtual engagement with the team was ask them what they're working on, because we really wanted to make sure that we understood the importance of the why, right? Yeah, data's great. Yeah, infrastructure's great. But really, how is it transforming people's lives? That's really the key. And to do that, we wanted to understand what the students were working on. And here are some of the things. Obviously, COVID is a big issue for everyone globally. I can tell you that in March of 2020, I was in Uganda and had COVID, and the resources there were basically non-existent. So I'm all supportive of bullet point number 1. And also, here's a list of the things that people have been working on. And this is what our office hours looks like. So we're really sharing screens with the students. This is a student named Ibra who's working on cattle genetics, and he's looking for, he was looking for loci, looking for disease tolerance with ticks. And so he basically, this is what we do. He pulls up a script. It's maybe not running efficiently, or it's not running at all. And so we just spend time going one by one through the code, trying to help them make it more efficient. So this happens at 9 a.m. our time every 2 weeks, and that's 4 p.m. in Uganda. And one of the things I really want to recognize about the students who log into this is it's 4 o'clock, data's expensive, and it's a big commitment for the students to come on this call and talk with us, which we appreciate. Dowdy, thank you for facilitating students showing up, and we don't just sit there, right, Shane? So this is one example of what we do every 2 weeks, code clinics, walking through with the students. Another thing that we've been working on is really trying to bring some of these, sort of data sharing, data management things to the teams and the students on the continent, which I think is a big push for everyone, and DSI seems to be doing that as well. So this last time, a student, Ibra, is finishing his project. Where is he going to put his code? Where is he going to put his data? Obviously, he's published it, but really trying to make sure, raise awareness around general repositories, what goes there. And also, I think one of the things that, Figshare was talking to us for other things, and they're like, oh, well, what do the partners in Africa want? And it's like, it shouldn't be me saying it, right? Come on this call and talk to African scientists, right? That's how you find out, is your Figshare thing accessible to these students on the ground, right? So that we're sort of facilitating those conversations to help these people that think they're doing globally inclusive things. Let's ground truth it. Let's really see, are students able to get on? Are they able to do those things? So, and I think also, one of the important things that we're doing through this is helping get students on this, ORCID IDs and all these things that connect scientists together, right? The footprint. Everybody acts like scientific papers and journals act like they have no reviewers. There's an entire continent of scientists that are ready to review papers, right? But finding them is really hard. So I feel like through these engagements, we're also empowering students and people to know where to put their footprint, digital footprint, so they can be found, so they can be included, right? And so this was last time we talked about Figshare. There were lots of questions, and we're going to keep working on these sort of best practices for sharing data. And then this is my last slide. Our next steps are, this is the selfie when we visited you, Dowdy. Everybody who knows me knows that we're going to take a selfie. I firmly believe it's a team building experience. So, Mike Moore, do we take selfies? We take selfies. So, the students have really wanted to learn more about cloud computing, about more making their code efficient, and then parallel computing. So over the next sort of 6 months, these are the things that we're going to be working on with the students. And that's all I have to say. I'm more than happy to answer questions at the end with everyone, but I wanted to keep mine short and make sure Dowdy had like the entire time, in my opinion, to speak. So anyway, I will pass to Chris.
Wow. Good morning, everyone. I'm Chris Whalen. I've been working as the International Program Manager for the last 20 years, and for 5 years before that, I was working in supporting the infrastructure that NIID has in Mali. So there's, I think, 4 really components that I've discovered over this time, which is going from right to left, people. From the very first time that I started building networks and infrastructure in low-income countries, it is about teaching people how to support that infrastructure. The people who are using it are also very important, but it's, I think one of the things that gets missed a lot is training the people to support it, and also training them to be able to work with scientists. Scientists can be very difficult people to work with. My wife is a scientist, so I'm allowed to say that. So, you know, of course, the internet is also absolutely critical piece of this. And then if you're going to run infrastructure locally, not just up in the cloud or in another continent, you need cooling and you need electricity. So I think one of the most important things that we are teaching is actually optimism. Because if you complain about something not working, it means that you believe it can work. And we have to, in many of these places, we're teaching people to be optimistic and to expect things to work. Because if they don't complain and if they don't try to fix it or tell us when something doesn't work because they expect nothing to work, then that's a complete lack of optimism. So one of the things that we have to deal with, and I'm going to go through some of the things that are really difficult about working in these regions and in these kinds of countries. Power is one of the biggest problems that we have, and it is probably the most fundamental problem. And that is, if you look at this graph, this is just from last week, actually, in our data center in Mali. And those are the 3 phases of one of our data center circuits. And those phases are this is the voltage, and they are supposed to be exactly the same. And as you can see, these phases diverge greatly, and they're not supposed to go up and down like that. So one of the other things is that about electricity, and this is this is a little plug check that I use when I go traveling around different places in West Africa, and I take a picture of it. And I went to on a tour of laboratories in Burkina Faso, Mali, Senegal, and in Guinea. And every one of the laboratories, I'd find an empty plug, and I'd plug this in and just to check and see what the power looked like. And if you can see on there, there's supposed to be 3 lights when it's a good plug. And I didn't have a single laboratory that had all 3 lights on. So you can't expect your basic infrastructure to work anywhere. So the other thing is, you can't also just build something in the cloud and expect people to be able to get to it. This is a picture of one of our board members, who's a scientist in Mali, Professor Jimdi. And this is the day the grant is due, and the power is out, and he has no internet in his house. So he's outside using his phone as a hotspot, trying to get the best connection he can so that he can get his grant submitted on time. So how can we do this? How can we build infrastructure that will operate and have people to support it? So one of the things that I've found is that some of the things that we think of as green technologies are actually the things that we can use to make more reliable, more sustainable infrastructure for data science in Africa and in other low-income countries. So we designed this learning center that you can see here. Everything in there is as low power consuming as possible. These are thin clients powered over Ethernet, and everything goes through a single switch that powers all of those workstations. The data center is in another location where we have more reliable power. And the only problem is that, we've got solar panels and we've got the batteries and we can run for 2 days without any power in that place. But it gets unbearably hot. And so the students have been bothering us actually to see if we can find some way to get green air conditioning in there. So this is a public-private partnership. NIAID is one of those partners, and Bioteam is another partner. And the Bioteam brought with them the Texas Advanced Compute Center, which has been an incredible resource for us. So they donated this entire rack of 8-year-old computers as a cluster. Bioteam configured it and set it up. And as they said, they're conducting regular office hours. And this is invaluable. Because nobody is running around donating, hundreds of cores of compute for these students who desperately need it. But to run that, you've got to have all those things to compensate for what I've been talking about. We need UPSs. Batteries, locally available batteries, are usually extremely low quality. So we have to bring in those batteries from other places. We have to buy local air conditioning if we can for that data center, because we need to be able to get somebody who can service it. We can send in a really nice air conditioning, humidity control from the United States or from Europe, but there's not going to be anybody there to service it. And even those air conditioners need to have regular voltage. You saw that graph earlier on. That voltage is jumping up and down. Our compressors are constantly burning out because of the bad voltage. So you really need to think all the way back to the very basic level. And not so much in Uganda, but in Mali, we have incredibly high level of dust and particulate matter in the air. And particularly this time of year, January through May, it's unbelievably bad. They get an inversion over Bamako, and all of a sudden you can barely see. So this, you have to really think about how you're going to keep that environment clean for the computing. But it's not all grim, right? We've been able to do some amazing things. With Bioteam in Uganda, we've got that rack of servers. We've got the power, largely donated by NIAID, and also Makerere University. We've got storage, donated storage, NetApp infrastructure that was donated. We've got virtual machines running on that infrastructure. And that virtualized server farm is actually providing that infrastructure that Dowdy was talking about in his talk. And it has a number of different operating systems that we're having to support. And this really gets into that problem of we need to have local support teams that are trained up and know how to support this, because the scientists are constantly pushing us to try new things and put different systems on there. And then you can see all of these services that we're hosting in that single rack. And again, we're running OpenHPC. We've got 224 CPU cores assigned to that. And at the moment, 448 gigabytes of RAM. They're using Slurm, which is taught to us by Bioteam. And then those physical servers and the storage are, absolutely critical. We're already running out of storage because this relationship with the South African sickle cell group, they're putting lots of genomes in there that they're using in the research. So this is just a few pictures of the Uganda compute core when we were putting in that server cluster from the Texas Advanced Compute Center. And then we're getting close to putting a new cluster in Mali as well. And we're also, hopefully, if I get a chance to present this again in a year, we'll have immersion cooling. And you can see there's the new rack that's coming from, it's actually being loaded into a container this week. We picked it up from TAC and Bioteam earlier this week, and it's being shipped to Mali for the students there. And I'll turn it over to Shane.
Good morning, everybody. I just wanted to start with this picture because Dowdy's in it, and it looks, you know, so bright-eyed right there, like, so. But yeah, these, you know, this is what I think of, you know, when working on this project. I think of all of these smiling faces and you know, the wonderful work that, you know, they're doing. Like everyone said, you know, the compute cluster, like Chris said, is, you know, eight plus years old. But you know, Stampede 1 was at one time, you know, number 6 on the top 500 supercomputers on the planet, and had a really good run. You know, with over 11,000 scientists served, and over 3,000 projects ran on that cluster before it was, you know, ceremoniously ripped apart and, you know, donated in multiple situations. So Uganda actually has one of these racks, and luckily, so do we at TAC. We actually have our own kind of sister rack to the Uganda cluster. So it's kind of handy. We know that hardware like, you know, the back of our hands. So it makes supporting these guys very easy. Like I said, you know, it's old, but she still has a lot of life in her, and you know, machines die all the time, and they finally just give up the ghost. But we're making it go again. So a lot of the stuff is you know, already been covered, but you know, the power definitely is a major obstacle that we have to go and face every single day. And obviously the internet, you know, downloading these data sets and sharing data between the different sites is not impossible, but definitely painful. So we would like to, you know, offer different services and different abilities for each of these sites in the future. So, so like Laura mentioned, you know, we're conducting the office hours and helping users really understand how to optimize everything about what they're doing. You know, you can't learn high performance computing really at a college setting. You know, it's tribal knowledge. A lot of that stuff is passed down from, you know, experts such as myself, you know, to the new crop, and you know, we help build them up and give them the information that they need to, you know, actually take care of these clusters themselves. So you know, we want to give them the information, give them the knowledge to be able to self-sustain. So one of the things that we're actually taking a look at very seriously is this idea of power and the lack of good power in these locations, and also the harsh environments that they live in. So, you know, things like ARM computing, even, you know, clusters of laptops with their own built-in batteries, so they can run 6 to 8 hours without these, you know, without relying on the grid power, which, you know, we definitely have to think about. And you know, submerging cooling is definitely something that could be used in those locations. We have a lot of hurdles with that as well to get over. You know, because if you've ever seen a submersion cooling system, it's not exactly the easiest thing to work with, but I think we can get over that hurdle. And then of course, yeah, solar. One of the big things that I would like to achieve in the next year or so is the ability for multi-site data sharing. Allow users in Mali to be able to directly access the data in Uganda and vice versa, and make that not so painful of of a process to share data and know what each site has, because we all know, I think, that data gets generated and then copied and copied and copied, and then you'll end up with 10 copies of the same data. No one knows exactly where it's at, what's going on with it. And so, I definitely, I don't harp on it enough, but I would like to more in those office hours, definitely train and help them understand what data management truly is and why it's so important. Because, teaching a scientist at the beginning of their career how to manage their data and how to take care of that data would be very, very powerful for them and their colleagues in the future. As Chris said, we just shipped another cluster to Mali. These are Stampede 2 nodes, so the next generation of the Stampede cluster. These are Knights Landing machines. So that is going to be it's not going to be a hurdle. But I think it will definitely have some challenges that we have to address at some point. These clusters are all built on OpenHPC using Slurm and Werewolf as the bedrock of each cluster. All stateless compute nodes, so they basically pop right back up after that. After the power going out, they'll be able to basically self-initiate and join the cluster and come back into a clean state. We wanted to make it kind of as easy and reproducible as possible. Even with the bad power that we constantly get hit with, and the researchers and students do, we've actually opened up our BioTeam cluster at TAC, and we've actually onboarded several students, and they're actually doing real science, on our old beat up racehorse at TAC. So it's very exciting to see those students pegging out compute nodes and doing real work. So this I really like this. I found this last night. This is a picture of something us yahoos at BioTeam came up with, and we all wrote one word on a big piece of paper that really kind of it shows what we are, I guess, most passionate about, or the thing that matters to us, right? And so everything about this project just screams BioTeam, right? It's what we do. We love to get in and find the gaps, and make recommendations and optimize things, but it's all about accelerating science and empowerment, which ultimately leads to the impact that the ACE program is having. So thank you.
This thing moves.
All right, so thank you to everybody for those wonderful talks. I think that was a really good overview of the program, the impact, the challenges, all of that. And so the rest of the time, and we were remarkably on time, good job, is sort of a panel, a discussion, questions, and so happy to open it up to the audience. If you have a question, come to the microphone here so that, or you just want to comment or something, so that the folks online can see and hear you. And otherwise, I will lead off. So I'll start with one of my questions while you all are deciding if you want to get up in front of the microphone or not. And this is open to the whole panel, but I'm going to direct it at Dowdy first. What happens, you sort of mentioned it, but let's talk a little more. What happens to the students when they graduate? Where do they go?
Yeah, thanks, Ari. So multiple parts. One, we see several of them, especially the master's students, wanting, because of the not the excitement, but the enthusiasm that they get around the science during their master's degree studies is wanting to go on and actually become better through getting PhD placements. So they typically do a lot of applications for PhDs. We have had a few of them go into research institutions in the country. So we have, for example, the Uganda Research Institute. We have a few of them who are right now supporting the Uganda National Health Laboratory Services. So this is the national institution that is mandated to do sequencing of all types of pathogens in the country. They have a huge need for bioinformaticians, so we have several of them going there. We also have some of them who actually circle back and work like teaching instructors on the program itself. I think you guys here call them assistant lecturers or something like that. We've also had, incidentally, some of them actually going into sort of science coordination and science management. When we first started, a lot of the students were biological background. In eventual cohorts, we've had some that are computational background, and a few of them are beginning to express interests in some of the stuff that you guys are doing. Management of technology, optimizations of technology, configurations of compute resources. So there are a few that are looking to go into that. And then some of them have ended up, a few of them have ended up at the Ministry of Health, doing stuff that is related to bioinformatics, but mostly on the data science angle, on the epidemiology angle. And actually what that has done is to show us that we need a little more epidemiology-based work. So, and of course, like I said in the talk, a few of them have ended up here in the US, working for the CDC, the Baylor College of Medicine, and I think somebody's is going to end up somewhere in Maryland with a, I forget what the institution is. So multiple pathways, and it looks like the number of those pathways are going to grow as the training improves, but also as the science and research terrain keeps evolving and spewing all sorts of new paths.
Awesome. I remember one of the measures that the ACE Global Council said yeah, come on up, was everyone who graduated got jobs. And that was a huge thing, you know, something we for sure take for granted here, but it's an amazing accomplishment there, actually. So thanks for that. Question.
Okay, probably this question is more directed on Chris. So I'm a hardcore scientist. And the way we saw the whole presentation, a lot is being done to increase the hardware locally. But what is being done to increase the internet capacity? There are tons of projects I personally have been involved in, like Rosetta and other places where we borrowed public computing spaces and people donated it for free. And we converted those projects beautifully. So instead of just doing the local hardware upscaling, can we do something on upscaling the internet itself?
You took one of my questions. Good job.
Okay. Well, thanks. It's a great question, and it's something that, you know, we think about a lot. The biggest, I mean, we just don't have that much control over our ability to get internet connections. Both of these countries are landlocked. Uganda has a much better infrastructure. They have a national research and education network that is one of the most functional NRENs I've ever worked with in the world. And they do a great job of providing that improved internet connections, and we're able to replicate. But a lot of this is really, it's necessary to have something locally. It's necessary to have something that you can get local engagement with. And having something that's on another continent somewhere else, it doesn't get people very excited. Particularly, I think, these were all colonial countries. So I think that there's also an aversion to having all of the data and all of the compute and everything happening somewhere else. And then I think the other thing is that in Mali, in West Africa, the internet connections and the infrastructure is just not there. And it's just not reliable yet. It will be. I think, you know, there's going to be opportunities with things like Starlink coming along and the other Starlink competitors that are going to make a huge difference. But again, I think if you don't have something there locally that people can learn on and see, and that sense of ownership, I think makes a huge difference.
I'm wondering, with all these challenges with the on-prem infrastructure, is the reason that more of an emphasis for cloud migration hasn't happened because of the internet issue? Because don't you need internet to SSH into the cluster anyway? So if the internet's down, you can't use the Slurm cluster unless I'm missing something.
You mean the local,
Yeah.
even locally within?
Yeah, I mean, don't they need internet connectivity within the lab?
Well, there's local networks within the
Okay.
universities.
Yeah.
And
If that's what,
It's a complicated issue.
Yeah.
Okay, it's a very complicated issue. So on one hand, everybody understands that the future is in the cloud.
Uh-huh.
No doubts about this. The current state of the internet connectivity slows down that transition to the cloud. But that's not the only obstacle. What you need to understand, and Chris mentioned this, the colonial past there is still very fresh in the people's mind. So the sharing of the data, moving the data into somewhere where they presume that they lose the local control over that data is a challenge. So until the cloud and the structure in the cloud will guarantee that they have full control of this, you will see the kind of mixed development. So more on-prem to keep that data locally. However, need for more computation will start forcing people into the cloud. Okay, we cannot continue to build, you know, all these HPCs locally. So it's a very interesting problem, which hopefully will be resolved soon.
Can I say something? I think it depends on where the data is generated, right? Like if it's generated overseas, which the majority of these big sequencing projects are, like if it's a student, maybe it's generated in, you know, Macrogen in Korea or whatever, and that's transferred to a cloud thing, then the student logs in. That's not a lot of bandwidth, right? And then usually the processing could happen in the cloud and then you pull it down, and that seems to be a thing. But if the data is somewhere local, trying to move that to the cloud would be that would be a big thing. So I think it's like, we've been trying to work with the students to have them think about the flow of the data. Sometimes it's local, sometimes it's being generated overseas, sometimes it's generated at Becca in Kenya. It's this interesting conundrum around its data size, right? Usually it's genomic data and it's big, but then once you process it, it's not big. But then where do you put the big stuff to store? Like it's this whole thing, you know? So, and even like people that have had exposure to the cloud, when you give them, here's your cloud account, nobody knows what the heck to do with the thing, to do what you want it to do. You know what I mean? Like the training, the ramp for this whole thing. So we're trying to, I think as a group, develop it all together, you know, get that comfortability on-prem, then have options for cloud and just sort of build capacity in that way.
yeah, absolutely. And I'll add a few more pieces to this. You know, as should be evident by the wonderful presentations, we take a lot for granted here, right? Not just the power, not just the infrastructure, not just the internet connection. I mean, you know, we're talking like an entire country has a gigabit to the internet, right? My house has a gigabit to the internet, right? You know, we're talking millions of people trying to fight for that type of connection, and then it's further slowed down by, you know, paranoid governments who have like way more than we are, you know, security and all sorts of things that really slow things down. But if you take a step back for a second, everyone's like, well, of course, cloud, it's infinite resource, why not? It's also expensive. right? And that's an issue, big issue. Even with organizations like the partners in this program, contributing as much as we possibly can, that gets pretty fast. I mean, they're running on 8-year-old equipment, right? That was donated very nicely, and it's good enough for them. Like it's more than they had coming from there. And then there's the thing, as a sort of former HPC engineer myself, right? I can say that one of the things that I'm fearful of with everyone saying, screw local, let's go cloud, is that we forget how to do it, right? And then only these very large public companies or private companies know how to build these things, right? And then they end up owning science and things like that, and these folks have an amazing opportunity to learn the fundamentals of the technology and to really become engineers who can design things for themselves, for their countries, for world health, right? In these spaces, and so there's an opportunity to train, like scientific IT, scientific computing folks who then can go and, on the supporting side of science, keep changing the world. So I think there's a lot of perspectives here.
Oh, thank you all.
No, thank you. Great.
Bringing back to people from infrastructure, highly impactful and transformational work that you're doing in these two places. Like, what is like outreach looks like beyond these two countries and transforming students from other countries? Dottie?
Thank you, Banu. Very, very, very important question, because the need is great. These are just two centers across a very, very big and diverse continent. Right now, there's been about 2 pathways. The first one is individuals from other countries just directly applying for user accounts on these facilities. For example, we have some users from the Sudan. We have some users from Kenya. And we've had approaches from individuals from the Congo. Now, of course, once it steps out of Uganda, then, of course, the internet issues become relevant. But so that's one pathway. The other pathway is that we get specific training programs. I mentioned the one that is related to cancer right now. There's another one that's related to another neglected tropical disease, schistosomiasis. And I think there's one related to trypanosomiasis. It's a trypanosome. So these are targeted projects that have members and fellows from across the continent working on those projects. And they also then come and request for accounts. So it's been mostly those 2 pathways. The other has been individuals, and we're hoping in about 6 months, individuals who apply to come and get trained on hardware, compute, the sorts of stuff that these guys are talking about. Because like Chris said, there's a huge need for those. And so when you have a center like this, it provides them an accessible local platform. And so you get individuals from Tanzania, Kenya, Uganda, Rwanda, coming and having their trainings on these facilities. Hopefully the network will grow eventually, but those are some of the few pathways that people are using to access or leverage these resources.
If I can add to this, so these centers were all designed to be regional centers, right? Not just for Uganda, not just for Mali. So Dawzi already talked about Uganda side. On the Mali, they actually opened their programs in the last 2 cohorts for the foreign students. So they're not only for Malians, they are also open for the students from other West African countries.
Just tagging on one more. Talk about the future of ACE, and is the program looking to expand to other countries, other areas, or what are we thinking? Mike, Chris?
Well, it's a good question, with no easy answer to that. So again, final goal here is, as I said, to get to the third phase of this, where it's actually becoming a self-sustainable service center for the biomedical research in those regions of Africa and ideally for the entire continent here. We are not there yet. Okay, we're moving to that. Again, it's all this, we always put a premium on education. I think for the entire presentation today, everybody was saying it's the most important factor, have people who know how to solve the problems. So we solve this stuff from the education and the post-educational training. So again, that's what I hope where it will go. I hope we'll get there in a couple of years. We already have some nice indications where people are putting the ACE infrastructure into their grants. So they're going to do the research on the grants. So the other thing here is, again, right now, and I think Dowsey brought that very important point. While we started with the area of the infectious diseases, and that's what the area of responsibility of the NID, as the life expectancy in those countries continue to grow, the non-communicable diseases are coming to the forefront, right? So right now, again, it's a huge issue of the infectious diseases, but now again, because people live longer, cancer, diabetes, other type of the non-communicable diseases becoming very important, and that's also probably the future of those centers working more closely with the other NIH institutes like Cancer Institute, Heart, Lung, and Blood, and so on.
Awesome, thanks. Go ahead, Andre.
Andreas Bonner from Y Cornell in New York. Thank you so much for the discussion. Learned a lot. I have a question on data governance and avoiding data replication. One example we have here is dbGaP. Everybody needs to get access to protected, or not everybody, but when you get access to protected data, as an investigator, you get a copy of it. Investigator next door needs to get their own thing, and sometimes we make another copy. Have you thought out to avoid, let's say, this replication of unnecessary replication of the data? And if you can share, your thoughts about it.
Wow. I don't know if I'm the best equipped to answer that question. A lot of this, I think, for us goes really back to training individuals how to use these resources. You're absolutely right. A lot of the conception now is people think about their research as individual projects. So I get my data set, I work on it, on my user account on the system, and then every individual has a copy of that. Most of it is because we have not yet been very well exposed to how to do this. And this actually extends to things like the ethics of data, the legal and ethical implications of data and how to manage and how to use it. But I think part of that is a technical answer, and I'll let my colleagues address that.
It's not only the technical answer, okay? So I'm not very familiar with the subject, so I'm not going to go into details because I don't know them. But NIH for the last year or so is actively promoting the use of the research authorization services, okay, RAS. So that type of the access, okay, allow you to basically have a direct access to dbGaP or other repositories that are included or will be included into the research authorization services frameworks. So you have your visas if you want to access that data once you are authorized and authenticated. But again, I don't know all the details. So you can contact Dr. Rebecca Rosen. She is one of the leaders of that project, and I'm sure she will be happy to give you more details.
Thank you.
I would also like to add, like on the local system, training the users to be able to, use sort of like a data commons on the system, right? Like all scientific data that, is pulled down can be utilized by everyone on the system because it's in some sort of like public repository on the local system. And then of course, you have things like deduplication, which can be utilized on the storage system itself. You can you can make as many copies as you want of that same data, and it's only going to, save the changes, and you're not going to, necessarily have, 80 copies of a BAM file, right? So you can do, there's multiple ways to look at it, and training, I think, is where it really starts.
Yeah, it's true. All the students we've dealt with have just local copies of things that they've gotten from somewhere. It's a little bit, they're focused on getting this analyzed and then getting their degree. And then, so that's why we're trying to help with the Fig share. Oh, let's think about this. Where are we going to put this? Where might we, because the data is the power, right? That's where the politicians and the people need to really govern the things that they're getting. It's it's value. So I think that over time, as we do this, we're going to try to work towards that mentality shift of putting it somewhere to make it fair, and all of those things is what we're really trying to work on, because it's such a powerful position for you all,
But I'll just add one more thing. The degree of data governance, which by the way still needs a lot of work in the U.S., is that we have here is somewhat a luxury that we have a lot of these things figured out. That's not the case in these countries. They didn't even have the ability to do this before. So data governance is like, okay, so do we have somewhere to put it? Is sort of where it goes, and then helping train them, as they said, to be like, okay, so let's think about this thoughtfully as a community and get some good data citizenship going, right? Those types of things are. It's important. I think it's foundational to the training, and starting with sort of, okay, let's just start right in on a data commons type of model, because for the permanent scientists there, once the students leave, probably going to want to use the data again sometime in the future. So rather than having to dig through files and folders to figure it out in lab notebooks, now it's there ready to go.
No, I think it's important. I mean, we have these examples of COVID sequences, right? Tanzania didn't add anything until like 3 years later. It's not because they didn't have the data. They didn't want to be burned by the system. But that's the truth of the situation, right? Like they had plenty of sequence data, and it didn't feel right to share. So the paper, I think, came out 6 months ago or something. The Tanzanians were so there's a lot of work, a lot of global work, isn't there, to building trust. And it starts with what you're kind of saying, let's organize it. Let's feel, this is what we're bringing to the table. This is how we share. This is what we do. Anyway, you have a question, sorry.
Hi, my name is Tatiana Kennedy from Nerds Therapeutics. Just wanted to thank you all for such a wonderful presentations. As someone who grew up in Zambia, and struggled to submit Word docs sometimes just to get an assignment done. Really, really cool to see where you guys have gone in terms of power. Anyways, my question was, as was referenced earlier, one of the main goals is to give the students the confidence and power and skills to kind of build their own career and kind of give back to what they got from the program. And a lot of these problems that I saw seem to be very interdisciplinary. And I was wondering if there are any programs going on with other students in the universities, maybe with electrical engineering or math, any of the other subjects in terms of creating these projects, maybe solving problems within the university community.
Daddy, that's all you know.
That's all yours.
That's all you.
You see, I get thrown under the bus.
Yes, you do. Yes, you do.
Just next.
Yeah, that's a very tough question. It's true, we started with the lenses of just bioinformatics and data science, and having students who are interested in that apply to the programs. But it is becoming very, very clear that the skill set needs to be broader than that. One of the things that we hope we're getting into right now is the training that is not bioinformatics classical, data science classical, but infrastructure training. How do you make these systems? So the kind of skill sets on this table, especially the last two gentlemen on the left and the guy, I think we can use these centers to actually do that sort of training, and then have individuals apply from engineering, from mathematics, and from all these fields that are different but important for these kinds of infrastructure.
I mean, somebody left out the batteries that are the backup that you guys engineered, right? Like
That's
Chris, did you, Chris? That's the cool stuff. The fancy solar thing.
Wow. I
Somebody
didn't
did
engineer
something.
those.
I mean, but the local community was there engaged to solve the problem, right? It seems like a partnership of,
Yeah.
Yeah, there's a rack of motorcycle batteries. Like,
Yeah.
I'm serious, like on a shelf,
Daddy, I'm
sitting
loving
outside
that.
the cube that houses the things in Uganda, connected to a transfer switch. That is kind of the local solution, and
Yeah.
it's actually brilliant. I saw it, I was like, this is amazing. Why don't we do this in the U.S.?
Because we don't need to.
Yeah.
Yeah, yeah. Again, a luxury.
So I'm Avi Gandamita. I'm an HPC engineer at Novo Nordisk. It's actually a really good segue to what I'm about to ask about. Is you talked a lot about dirty power and how that's a problem. Have you considered going upstream in the power generation and investing in that infrastructure? Maybe even using the compute demand as a catalyst for energy production in the area?
That's Chris.
We've tried talking to the utilities in both countries, and it's they're not used to this kind of infrastructure and this kind of demand. And I think that it's going to be a few years before it sort of reaches the level of importance. I mean, right now there's a lot more important things. Making sure that hospitals, for example, have reliable power is probably higher on their priority list than our HPC. We may think differently, but so I think that that once we get past that, it's definitely going to be important to them. But it's a good question.
If I can add, there was a great talk here yesterday on decarbonizing in West Texas.
Yeah, I saw that.
Yeah, how they're moving compute to where the renewable generation is.
Mhm.
Yep. I wonder if there's some kind of synergy or alignment there with what you guys are doing.
Yeah, it's just that's there's no place in these countries that has that, like where they were saying West Texas has almost zero cost power. There's nowhere we can move that's within the country or within the region really that's going to have that.
And I think part of the sort of post-colonialization type of things here, as Laura said earlier, is there actually needs to be a sense of ownership to this, right? They need to our whole goal is to empower the local people to be able to really be able to do this stuff. And so if it's shipped off to West Texas, they'll be like, hey, we can get our science done. They'll get lots of papers and all that. But, what happens, that doesn't go towards a sustainability effort in these areas either, or a growth mindset for the country. So
thank you.
It's a good question, but it's super hard.
Zhen Xiao from Leidos. Right now, I'm leading the partnership and strategy for Leidos life science practice area. And since Leidos is a defense contractor mainly, I'm sitting here listening to the wonderful program and your goal to make it a self-sustainable facility in Africa. I wonder if you have conversation with the military because they deal with the same rugged environment, the same power issue, same infrastructure issue. So I wonder if you have that kind of conversation already with the US Army, for example. This is one question. The second question, again, I'm thinking the similarity between the Africa countries and our own Indian tribe and also the remote area, how we are going to learn from this experience and this exercise and also address some of the similar issues domestically. So I want to hear from the panel.
Good question.
You talking to the military, Chris, or what?
Yeah, I mean, those are two really good questions. So a lot of the tech that has been developed for the U.S. military is at a price point that we don't really have access to. And since most of what we're doing is on a donation basis, all of the hardware has been donated. You know, we've had Intel donate servers, we've had the Texas Advanced Compute Center donate servers. We would, you know, we will use whatever somebody is willing to donate. So, you know, if we were to get hardened systems, I think it would be amazing to be able to do that. But the whole ecosystem that supports that infrastructure would have to come with it, right? We need to be able to train people there to support it. And, you know, for example, specialized cooling systems or specialized hardware is going to require that kind of specialized expertise to support it. And that it's hard to sustain that. And then as far as I think the tribal colleges in the United States, I think there are a lot of opportunities there. We've been working for a number of years with Internet 2, which is making a big effort to support both the HBCUs and the tribal colleges. And I think that there's definitely you know, an opportunity for collaboration.
And I think I wanted to say the tribal reservations, it's a really good point. I don't think people realize how similar these environments actually are. Even though it's sort of located in the U.S., it is, you know, the access to things there are really, really low. So it's a good point to transfer some of these lessons.
Yeah, in addition to the infrastructure similarity, I also see the data governance policy.
Mm-hmm.
Because in Africa, you don't want the data leave your country. Here, the tribes, they don't want their data to leave their territory.
Yes.
So how do we, in addition to think about data transfer, but how we get the information, the insight, the model out without touching the data? So those are the future opportunities.
For sure.
Again, I want to thank for this opens up a lot of future conversation and opportunities for all of us to partner. Yeah.
Thanks, Jen.
Thank you.
Yeah.
Thank you.
Fernanda?
Hi, folks. I'm Fernanda Forder with Voltron Data. One of the things that I was thinking about as you spoke about the students leaving and coming to the U.S. to do their postdocs here, it struck me as part of the sustainability is essentially talent leaving the country. Now, we've done a great job of training them, and now they've left. I have an employee in Zimbabwe right now, and the biggest issue that we have, the biggest hurdle that we have is, and she's actually our second employee in the continent, is paying, just straight up PEO, getting her pay into her bank account. And for us to be able to take advantage of the enormous talent that exists in the continent, how are we doing with just basic things like, can we have employees that are located in these nations and pay them there so the talent stays there and grows, you know, continues to grow within the country?
Right, absolutely. I think one of the benefits of the post-COVID world is more acceptance to remote working. And absolutely, to the extent that that is possible, that individuals can stay on the continent, but where necessary, do work here for individuals here, that would be absolutely great. And some of them are already doing this. Interestingly, I actually have two colleagues that I know that have relocated back to Uganda from the US, only because their jobs in the US now allow them to do that sort of thing, to actually work remotely 100%. Wink, wink. So absolutely, I think this is something we should consider as a post-COVID thing, how we can encourage people to stay, but also still have access to opportunities and challenges beyond their own local environments.
But Dowdy, does it, like, I can open my phone, get on Remitly and send somebody money, mobile money now, right now, right?
Yeah, in
So
terms of
it
payments, yeah.
requires like these companies coming to the table in a way that works for the people that they're hiring, right? Because I can literally send money for 99 cents on Remitly.
No,
to
it's not
peeps.
that easy.
I mean, like,
It's not
you
that
can,
It
you
depends
can.
on the country.
It depends on the country. There are a lot of local
Yeah.
regulations.
Okay, like in Uganda, I can send right now.
Well,
In
Uganda maybe,
Sierra
but-
Leone, I can send, I don't know about, but it's possible, right? It is possible. Mobile money, they're further ahead and advanced in their digitizing money,
But-
right?
but
We just
you
have
put-
to come to the
You're
table.
putting people in danger, okay, because of the local authorities there and local regulations. We have this type of the situations because again, we working in over 120 countries in the world. And there are some places which are very strict on the any foreign transactions
that's
that
true.
are coming, you know, so it's a local tax code. So Chris can tell you from his experience
what's
that
the
probably along with the network engineers, the second most important part job is a lawyer for the company
No, I get
that
it.
he is employing in the individual countries. It's not that easy, unfortunately. It's not like you can vend more money to everybody.
I get,
You,
I
you
get
want
it.
to
I
protect this.
get it.
You want to protect people who are working for you and not to put them in trouble because you're forcing them to violate some kind of
No,
local
I
law.
get it. They think that if you're sending large amounts of money to Uganda, that you're supporting Bobby Wine, the opposition leader, right? Like, I understand that, but it's not that it's not there. It's just that the regulations
In
around
some
it.
cases, it's not there.
Okay.
There, I mean, for example, in Mali, when they first had the coup, a lot of the bank relationships
that's a
severed,
mess.
and there was no way to actually pay people. Zimbabwe is a good example because they have a non-functional monetary system.
All right, so
fun.
give a round of applause to our wonderful panel here. Thank you all.
Money.
Thank you, everyone, for being so interactive, and please come help us support this wonderful effort. And we'll turn it over to the next set of speakers now. Thank you.